Let's take a look at the PPT's explanation of this. Let's sort it out. The first is flooding. Under what circumstances will we flooding? The switch received a data from an interface. If this data is a broadcast data, the switch is directly flooding. If the data is a unicast data, and there is no corresponding destination MAC in the MAC address table, then exchange chance flooding. So what is forwarding? The switch receives a unicast data, and there is this in the MAC address table. Then it forwards. And what is discarded? It's what I just told you. The switch finishes receiving data from an interface. Also send out from this interface. It will discard this data. This is the switch forwarding behavior. The switch also has a working behavior called learning. That is, learn autonomously. The switch can learn automatically. You don't have to configure it. So some people will say that the switch can be used when it is turned on. You don't need to configure it. That's why it works by itself. Here's some of how the basics of the switch work. Next, these are: forward data frame, the initial state of the switch, learn MAC address. Let's take a look. Just started without a MAC. Sent a data. Learn the MAC under interface 1. Then broadcast. This is an ARP request. Obviously sent. Host B replies to host C. Learned host C under interface 3. This is the MAC address. It's the same as the picture I drew. It's just that it's painted more professionally. Next we start talking about VLAN. VLAN is called Virtual Local Area Network. V is virtual. LAN is local area network. Why do we have a virtual local area network? Let me first describe an environment. In the future, many devices will be connected to one switch. Suppose a switch is connected to 40 devices. Let's just draw. 40 devices is a lot, because the switch has 24 ports and 48 ports. For example, now a device is infected with a virus. This virus is flooding by broadcasting. Then it will infect all other devices. That is, it now affects other devices intermittently, regardless of whether it is in the same department or not. Everyone is connected on a switch. It causes all devices to infect. For the company's internal, everyone will find. In daily life, some of our businesses also need to be quarantined. I give a simple example. For example, your company's R&D department. Usually there are some research and development data or some samples stored in internal server. There are some PCs in the R&D department that cannot even connect to the external network. There will be a lot of core data in it. For business, any PC is now connected to a switch. Actually, we are exposed to the possibility of information leakage. It's all very common. So everyone will find. If all devices are now connected together, connected to a switch, then relatively speaking, there will be a security risk. Whether it is a security risk, or for our business isolation, the actual demand between departments is not well controlled. We have another solution. Just get a separate switch for each department. When you study, you will have this idea. In fact, this idea is correct. Indeed. But it's that expensive. So often we say from the perspective of cost saving, we prefer to buy a device. Just be able to get the job done. So for us now, we just want a device. Can do some of our traffic isolation. For example, a host has a virus. Less impact on other devices. Same. 40 hosts now. Maybe 8 are from the HR department. 6 are from the sales department. 7 are from the technical department. The business between them can also be isolated. Can communicate directly with each other. But I want to ask you a question. When we were learning VLAN, is often the easiest to confuse with a thing. You may have heard the saying before. Different VLANs are different broadcast domains. There is no connection between different network segments. If you can figure out between different network segments, need to find a gateway across network segments. Going to the third floor is also impossible. Then it should not work on the second floor. Some may think. Just configure different network segments for the following PCs. For example, here is a PC. I am 192.168.1.1. The PC on the right is 192.168.2.1. The two of them don't understand each other. If I now draw different network segments for different departments, they are all connected to a device. They also don't work. VLAN also does not work. Different network segments do not communicate. I simply configure it as a different network segment. It doesn't work. So everyone should know. Communication between different network segments. We mean unicast failure. You visit 192.168.2.1 from 192.168.1.1. This is called unicast communication. Then it is the three-layer routing and forwarding. 2.1 according to the destination IP. To query the routing table on the gateway. Then forward. It is a unicast forwarding. Unicast does not work. If the unicast cross-network segment, you only communicate on the second floor. Do not configure a gateway for it. This is absolutely not going to work. But you need to know. Unicast fails but broadcast works. Now this PC1 sends a broadcast data. After the switch receives the broadcast data, its processing behavior is flooding. So as long as this data is a broadcast data, this data can reach the device. As an internal company, virus infections are often broadcast, rather than targeted strikes. Not trying to infect a single device alone. Usually broadcast. So in the form of dividing the network segment, there is no way to isolate real broadcast traffic similar to viruses. It has nothing to do with what kind of data is now. It is related to the forwarding principle of the switch. As long as it is a broadcast packet, even if you divide it into different network segments, where should this data go or where? Everyone can receive. So you have no way to solve this problem. We can only solve it by means of VLAN. Everyone should have an understanding of VLAN. The different broadcast domains it's referring to are. In the future, broadcasting will not work either. This affects the forwarding behavior of the switch. That is, VLAN is configured on the switch. Due to the configuration of the switch, then you can target different interfaces of the switch. Divide it into different VLANs. To control future broadcast traffic. The same is true for unicast traffic. That is, from which interface can all the traffic be sent out? They will not transmit broadcasts between different VLANs. So it can be isolated. I simply give an example. For example, now I divide this interface into VLAN 10. This interface is also VLAN 10. But this interface is VLAN 20. If this device sends viruses out in the form of broadcasting, then it can be broadcast from this interface. But this interface doesn't work, because they cross VLAN. Different VLANs are different broadcast domains. Packets from different broadcast domains cannot be sent out. This is the behavior control that the switch does. A forwarding behavior of its own. So the broadcast domain we're talking about actually means a delivery range of this broadcast message. So the interface of the switch. Flooding is the default for broadcast packets. And I tell you, All interfaces of the default switch belong to the same broadcast domain. Different VLANs are different broadcast domains. But unfortunately, by default, the switches are all in the same VLAN. If you want to control it in the future, you need to configure it separately. Okay.